What is up, people, and welcome to another video. In a previous video, we've taken a look at how to create a RabbitMQ instance, the basics of message queuing, how to create an application that consumes the queue and produces messages for the queue. In this video, we're going to be taking a look at the RabbitMQ clustering basics. So we're going to take a look at how to spin up a RabbitMQ cluster and what it takes. If you like the video, be sure to like and subscribe, because in the future, we'll be taking everything we've learned and we'll take a look at how to spin up a highly available RabbitMQ cluster on Kubernetes. So without further ado, let's go. Now, the RabbitMQ has a very good document on clustering. If you take a look at the RabbitMQ website, they have a full clustering guide showing you everything you have to know to get a cluster up and running. So the first thing we need to know is how RabbitMQ nodes are identified. Now, RabbitMQ uses node identifiers in order to communicate to one another. This usually contains a prefix and an @ symbol and then the host name. So in this example, I'm going to just keep the prefix constant. I'm just going to call it rabbit, and then I'm going to say @ symbol, and then I'm going to use the container host name to run our RabbitMQ instance. This leads me to very important requirements for clustering. The first one being host name resolution. So if we take a look at the RabbitMQ identifier, the second part of the identifier is the host name. This is very important for RabbitMQ instances to communicate with one another, and it's important that they're able to resolve DNS. So if you're running inside Docker, you use the container names. You want to create a Docker network to make sure that they can resolve each other's host names to connect and form a cluster. If you're running on Kubernetes, you want to make sure you're using something like a stateful set instead of a deployment, because a deployment has randomized pod names, and you want to make sure that each RabbitMQ instance is individually addressable. If you're running in the cloud like EC2 instances or Azure VMs, you want to make sure that the VM names or the EC2 host names is what you use to form the cluster. This is because host name resolution is very important for RabbitMQ instances to find each other. The other one is port access. So the important ports here is 4369, which is the discovery port used by the daemon. Also, these two ports are what we used for applications to interact with the queue. And then we also have some other ports as well as the management port, which is important for running the management dashboards, which I'll show you today. When we take a look at how to run this on Kubernetes, we'll take a much more in-depth look at the ports, because we'll have to expose every port individually. In this guide, we're going to be creating a Docker network, so all the ports would be open to each of the instances. So if you're new to this channel, everything I do is on GitHub. If you head over to the Docker Development YouTube series GitHub repo, everything I do is in the messaging folder in RabbitMQ, and then we have a README file that has all the steps I'm about to show you today. So be sure to check out the link down below to the source code so you can follow along. So the first thing we're going to need to do is set up a network so each of the RabbitMQ instances can talk to each other. So I'm going to say Docker network create rabbits. I'm going to create a network called rabbits, and every Docker container I launch is going to be part of the rabbits network. You can run the container saying Docker run -d and then pass in using the net flag, and that's how you run a container on a specific network. The next step is it's very important to know what data is replicated in a RabbitMQ cluster. So for that, they have a document on what is replicated. Now, it's important to note that not your queues and messages are replicated by default. It's basically just all data state required for operation, which is replicated across all nodes. So in order for the cluster and RabbitMQ to function, all the critical data is replicated by default. So in the first step, we're just going to take a look at how to get this running. We're going to spin up 3 RabbitMQ instances and have them join a cluster. We'll then take a look at mirroring and how to mirror critical queue data like queues and messages across between different instances. Now, before we spin up our RabbitMQ cluster, it's very important to know how do each of the instances in the RabbitMQ cluster authenticate with one another. So if you look at the documentation, you'll see that the Erlang cookie is used to connect and authenticate with RabbitMQ instances. This gets used by the RabbitMQ CLI to talk to the RabbitMQ instance. So if we run RabbitMQ CTL, but it's also used for instances to communicate with one another. So when we create an instance, we say Docker run -d, we run run an instance on the Rabbit's network. We pass it a host name because that's important. We also give the container a name, and we're going to run RabbitMQ 3.1. And when that container is up and running, you can go ahead and grab the Erlang cookie from the var lib RabbitMQ erlang.cookie file. So that will print out what the Erlang cookie is so that you can use that. You can also generate your own one and use that for each of the instances to talk to one another. So now that we know the requirements and we know the authentication, how do we form a cluster? If we take a look at the RabbitMQ document, they have a document on cluster formation, and there's a couple of ways to do this. Now in this demo, we're going to be taking a look at the manual cluster creation so that we can understand the core fundamentals of creating a cluster, and then we can automate that manual process by using the declarative config file. So then we're going to take a look at how to create a config file so that we can boot up these nodes automatically, and they can automatically find each other on the network. And then it's important to know that there are other methods of discovery. So if you're running an AWS, you want to look at this one. If you're running in console or etcd or Kubernetes. So in a future video, when we take a look at how to run this on Kubernetes, we'll be using the Kubernetes discovery plugin. Okay, so to form a manual cluster, what I'm going to do is I'm going to create 3 Docker containers with RabbitMQ. So I'm going to say docker run -d. I'm going to run them on the Rabbit's network. I'm going to run them with separate host names. So you can see I have Rabbit1, Rabbit2, and Rabbit3. I then also give them separate container names, and I'm going to run the management version of the container. So the management dashboard is also enabled automatically so that we can get access to the user interface. And I'm going to expose the management dashboard over 3 separate ports. So for the Rabbit1, I'm going to use 8081. For Rabbit2, I'm going to use 8082. And for Rabbit3, I'm going to use 8083 so that we can open up 3 separate dashboards and see the clustering in action. So I'm going to go ahead and grab these 3 commands and I'm going to paste them in the terminal. So now that that's done, we can see if I do docker ps, we have 3 RabbitMQ instances up and running. And now I'm going to open up 3 separate dashboards for Rabbit 1, 2, and 3, and I'm going to log in using guest as the default credentials. So now you can see I have my 3 dashboards open, and all of them are just running single node instances. So I have Rabbit 1 on the Rabbit 1 dashboard. On the second one, I have Rabbit 2, and on the third one, I have Rabbit 3. So they're not part of a cluster yet. We can also confirm this by running the rabbitctl command and running the cluster status command on one of the instances. So here I'm saying docker exec and I'm running it on the Rabbit1 container. I'm saying cluster status, and you can see that the cluster name defaults to the name of the container. And if we take a look at running nodes, it just has 1 instance. So to form a cluster manually, it's important to know the process and how it works. If any existing nodes need to join a cluster, they will lose all the data that they have stored already. So what we need to do is we need to run the reset command on every node that would like to join the cluster. Next up, we're going to need to choose a node we'd like to join to. So in this demo, I'm going to choose node 1. That means I need to go to node 2 and 3. I need to reset them to lose their data, and then I need to add them to node 1 to form a cluster. So to do that, it's very simple. You can see I have commands here to join node 2 and 3. So what we're going to do is we're going to say docker exec on node 2, and we're going to run several commands on that node. We're first going to say stop the app. This will stop the RabbitMQ process, but still keep the container running. It'll then say reset to reset the data and the configuration of that node. And then we say join cluster Rabbit1. So it's going to go ahead and join to Rabbit1 instance and start peering with it and pass the Erlang cookie across. So we need to run our instances with the same Erlang cookie as well. And then we're going to go ahead and say start the app back up and then report the cluster status to make sure they have been connected. And then we're going to run the same process on the third instance. Now notice that this won't work because we need to run it with the same cookie. So because every container that we're running now has a different Erlang cookie, they won't be able to authenticate with one another. So I've gone ahead and deleted those containers. And what we're going to do is we're going to run the same commands to spin them up, but this time we're going to pass the Erlang cookie environment variable of the cookie value we would like each instance to use. So note that they're all the same. So now I'm going to copy that command and I'm going to run all 3 of them in the terminal. Now we have 3 RabbitMQ instances up and running, and they're all running on the Rabbit's network, and they're using the same Erlang cookie, so they'll be able to connect. So now what I'm going to do is I'm going to go ahead and grab these commands and run them on node 2. So you can see the instance stops, the instance is resetting, it's joining the cluster, and it's starting back up. And then we can run the cluster status command, and when we do so, we'll notice that if we look at running nodes, we now have 2 nodes as part of the cluster. So if we head back over to our dashboard, we can now see that on dashboard 1 of Rabbit Rabbit1, we have 2 instances running. Now we need to do the same thing on node 3, so I'm going to grab that and I'm going to paste it in the terminal. And if we go back to our dashboard, we should see all 3 of the instances on all 3 of the dashboards. That means we've formed a cluster with 3 instances successfully. Now, because we've set up our cluster manually using Rabbit CLI, and also because we're running our instances inside disposable containers, when a container gets destroyed and recreated, the container's state is lost because we have not implemented persistence. So if I go ahead and delete Rabbit1, when it comes back, will not be able to rejoin the cluster. So learning how to form a cluster with the CLI is good for learning purposes, but you probably want to set up a more automated way by using a config file. So if you take a look at the Docker development guide, I have a RabbitMQ folder, and what I've done is I've created a config folder under that RabbitMQ folder that represents a config file for each one of our Docker instances. So I have one for Rabbit1, Rabbit2, and Rabbit3. And if we take a look at that config file, we can actually describe all the peers that we want to form a cluster with. So we say here cluster formation, peer discovery, backend, and we basically let RabbitMQ know to use the classic configuration file mechanism for discovery. So here we say we have node 1, node 2, node 3, and you can have any number of nodes in this list. And then we specify the host names of the containers that we want to form a cluster with. So now when our RabbitMQ container comes back up, it looks at the config file and knows where the peers are. So it will rejoin the cluster when it gets destroyed and recreated. So what I've had to do is I've gone ahead and destroyed the 3 containers manually, and now we're going to take a look at how to set up the automated clustering. So I have my 3 Docker run commands, and they look slightly different now. What is different? Well, if we take a look at the command, it's Docker run, we join the Rabbit's network, we then mount in our config file. That's the config file on the left here that we want to use, and we also specify with an environment variable where we want that config to be located. So I'm mounting it into a custom folder called /config/RabbitMQ, and then I'm also providing the RabbitMQ Erlang cookie, and then I'm setting the host name and the port as we did before. Now the reason I have 3 config files is I'm mounting 3 separate volumes into the 3 different containers because RabbitMQ needs write access to that config. So if you mount one config file into 3 different containers, they're basically going to override each other's files. So that's why I've separated it out. So now to start up the container, we can take this command, we can go ahead and paste it in the terminal, and we can run our instance. So that's going to create our first instance. We're then going to go copy and paste and create our second instance, and we're going to do the same and copy paste for the third instance. So now if I do docker ps, we have our 3 instances up and running. Now because we've specified a config, these 3 containers will automatically try to find each other and form a cluster. So we can head back to our dashboard, and we have our 3 instances up and running, and we can go ahead and refresh this, and they should start peering. And it takes about a minute or so for this to happen, but now when we refresh each dashboard, we can see the cluster has now automatically formed on each one of them. So you can see if I go to each one of them, they now have 3 instances running. Now I'm going to leave this clustering guide document with you, and be sure to take a read through this. It's not a very long document, and it has a lot of good information about how RabbitMQ behaves in a cluster. It's very important to understand what happens when a node gets rebooted. How do other nodes attempt to contact that node, and what happens when all the nodes go down at the same time, and also what happens when they all start up again at the same time. How does RabbitMQ rejoin and repair these clusters automatically? The other thing to notice as well is that when we start writing messages to one of these instances and we reboot them, the messages and the queues will be lost. That is because RabbitMQ by default only replicates operational data between instances to make the queue function. So if we have an application that produces a message into a custom queue, that queue and that message will only be available on the instances that that application has spoken to. So if an application makes a connection with Rabbit1, creates a queue and puts a message in that queue, and then Rabbit1 dies, the information will be completely lost. This is where mirroring comes in. Now basic mirroring is implemented using classic mirror queues. So in this guide I'm going to show you how to enable and set up classic mirroring so that our message can be automatically mirrored to all instances in our cluster, making our cluster highly available. Now it's also important to understand that by default, as I mentioned before, the contents of a queue is located on a single node. So that's why we need mirroring enabled. Now mirroring is enabled through policy. Now this document shows you how to enable classic mirror queues, and now it's enabled through this thing called policies. So policies are something we can enable onto a queue, and when applications use that queue, we can then implement mirroring on that specific queue. And there's also a lot of configuration that you can look into about how the different modes of policy can operate. So we have different HA modes like exactly, all, and nodes, and they have different behaviors of how each of the mirrors behave. Now the first policy is specifying how many instances you want to mirror to. So you can say exactly 1 or 2 or 3 number of instances. It'll go ahead and replicate to those number of instances automatically. Or you can specify all, which means every instance in the Rabbit cluster will get a copy. This seems like a good option, but it's not always recommended because it has a lot of compute overhead. It's always recommended to use mirroring to a quorum. So if you have, for example, 5 instances of RabbitMQ running, you might want to only mirror to 3 of them. The other option is using specific node names. So you can say that's only these specific nodes should be mirrored to. So that's a list of node names. So we go into Rabbit1, and then we're going to run the RabbitCTL, and we're going to set a policy called HA Federation. And here we're going to specify some regex. Now, depending on the name of the queue, you might want to run a regex statement here to match only specific queues in your Rabbit cluster. So I have gone and written a regex that'll just match to all queues, and then I set my upstream to all. I set the HA mode to nodes, and then I pass in the list of nodes. So that's the policy I showed you guys earlier, where you can pick different type of HA modes. And then I also set a priority to this policy, and then I apply it only to queues. So I'm going to go ahead and grab this, and I'm going to go ahead and run it. So now that we've created a policy, every single queue that we create in this RabbitMQ cluster will automatically be federated to Rabbit1, Rabbit2, and Rabbit3. It's also important that you need to enable the RabbitMQ federation plugin on each one of the instances that's part of your cluster in order for the federation policy to work. Now, to test out the federation, we need an application that writes messages to the queue. Now, in my Docker development GitHub repo, I do have an applications folder, and I have a consumer and a publisher. So the publisher puts messages into the queue, and the consumer will read messages from the queue and consume them. Now, in a previous video, I did showcase the code. If you check the link down below, I'll show you the process of how these applications were written, but they're basically just 2 little Golang applications. So we have in the publisher folder, we have a Docker file and a publisher.go, and in the consumer folder we have a Docker file and consumer.go. So to build this application, I'm just going to change directory into the applications publisher folder, and then I'm going to run docker build, and I'm going to build my publisher in a Docker container. So to run and build the publisher, I do have the commands listed in the README if you want to follow along. I say docker run interactively, I run it on the Rabbit's network, and I pass the connection details. So we're going to start writing a message to the Rabbit1 instance, and then I pass the username and password, and I'm going to expose this application on port 80, and I'm going to pass in the name of the image. So I go ahead and copy that, I paste it in the terminal, and we now have an application up and running, as you can see here. I can then open up an application like Postman, and I can post a message to the publish endpoint saying hello. So if I send that, we can see down here our application publisher has received a message hello, and it's published it successfully to the queue. So now if I go to my Rabbit instance 1, since our publisher put a message into that instance, we can see we're starting to see activity here. If we head over to queues, we can see our publisher queue has been created by our application, and notice here that there are some features applied. So we can see our policy has taken effect on this queue. If we click into it, we can see here that we have 2 mirrors running. So technically our Rabbit1 instance is our master, and the other 2 instances are mirrors. Now, it's very important to understand how the mirroring works in terms of master election. So basically what happens is, because our application wrote to Rabbit1, the other 2 instances are just part of a mirror. So the data will be mirrored across to the other instances. If Rabbit1 container dies, what will happen is one of the other 2 mirrors will become the new master node. And then when Rabbit1 comes back and joins the cluster, it'll just become a mirror. So if I go ahead and kill that container saying docker rm, and I kill the first instance, we can now see on our dashboard for Rabbit1 that we cannot connect to this dashboard. So this instance is now down. If I go to Rabbit2, we can see that there's still activity. So the queue is still persistent there. The data activity is still there. We can see that node 1 has been lost from the cluster. And if we head over to queues, very importantly, we can see because our queue has the HA federation policy on it, if we go in there, we can see that node 2 is now the master and node 3 is the mirror. So if I head over to node 3, we can see exactly the same same data being represented here. And if we go to queues, we can see the queue data is also on node 3. Now let's see what happens when I bring node 1 back. So I'm going to copy paste this command again to spin up node 1, and I do docker ps, and we can see now our rabbit 1 is back up and running. And now if I just ask a random instance like rabbit 3 and I look at the number of nodes, I can see all 3 of them are now joined. So rabbit 1 came back and joined the cluster. And if I go to queue data, we can now see that there is a red icon here. And if we click into this queue, we can see that node 2 is still the master, but node 3 and node 1 are now the mirror, but node 1 is unsynchronized. Now, it's also important to know, as part of HA, not all mirrors are automatically synchronized when they come back and join the cluster. So to enable automatic synchronization, we can do that through the same policy, but we can apply an HA sync mode automatic on that policy. So what I'm going to do is I'm going to go back into Rabbit instance 1 by saying docker exec -it, and then I'm going to apply the changes to the same policy that we created before. But this time I'm going to say HA sync mode automatic. So when I do that, we can see now we've updated the policy automatically. And now what I'm going to do is I'm going to add another message to the queue, and we're going to test to see if that mirror automatically synchronizes. So now if we take a look at the queue, we can see that the mirrors have automatically synchronized. And if I go ahead and I add another couple of messages to the queue, we can now see we've got activity again. We have a total of 5 messages in our queue. And now we can also see that node 2, rabbit 2 is now the main master node. So what I'm going to go ahead and do is say docker rm -f. I'm going to go and delete node 2 to see how the queue is now federated and synchronized. So if I go on to node 3, we can now see that RabbitMQ2 is not running, so it's down. And if we go back to queues, we can see that if we go into our queue, rabbit 3 is now the master and rabbit 1 is now the mirror. So the last node that joins the cluster always becomes the next mirror in line. And then if I start node 2 back up and I enable the federation plugin, node 2 should now be coming back up and automatically synchronize all the data. So now we can see node 2 is coming back up and it's up. And if we go to queues and we click on our publisher queue, we can see that rabbit 3 is still the master. Node 2 has joined as a mirror and automatically synchronized across. And if I head over to node 2 to test it out, I go into queues and I go into get messages and I say, give me the last 10 messages. We can see that it's got all the messages replicated into every instance of RabbitMQ. So hopefully this video helped you guys understand the basics of RabbitMQ clustering, how the clustering works, how to set up one manually, and how to set up one using a config file. If you liked the video, remember to like and subscribe, as in the next video I'll be showing you how to run the same style of cluster on a Kubernetes cluster. So in that video, we'll be taking a look at the YAML files, persistent volume, so we can store persistent data on a cluster. We'll take a look at the Kubernetes discovery plugin for RabbitMQ and how pods can connect to each other to form a RabbitMQ cluster, highly available cluster in the cloud on Kubernetes. So let me know down in the comments below what sort of videos you guys like me to cover in the future. And as always, like and subscribe, and until next time, peace.